Hello, my name is Ryan from Buster Beagle 3D. Today I wanted to talk about the Buster Beagle 3D Injection Molding Machine Mark III. It's the latest in a series of home DIY desktop injection molding machines that I've released in the last year, and now incorporates a pneumatic cylinder and a shot size of 3 cubic inches. So how can you make your own, and how does it work? Well, let's find out. So what exactly is this? Like I said before, this is a do-it-yourself injection molding machine that I provide plans for so that you can build your own machine at home. This is the third model in a series of DIY injection molding machines that I have put out since last year. You can check out the smaller hand-operated 1.3 cubic inch shot MK1 or the larger 2 cubic inch shot MK2 versions of the machines at the link above. This is the newest MK3 version of the machine. It has a shot volume of 3 cubic inches and achieves the pressure from a pneumatic cylinder instead of a manual handle. This build does not require you to have any major shop tools, as all of the custom stainless steel components, as well as these aluminum milled plates, are available online in my shop page, and other components can be purchased off the shelf at many online locations, except for the 3D printed enclosure, which I provide free 3D files for. This build is not sold as a complete kit or as a pre-built machine, but I'm working with a vendor who will be bundling the frame components together and eventually many of the pneumatic components to make it easier to source many of the parts. So rather than go over the build of this machine step by step like I did in the original Buster Beagle 3D injection molding machine video, I thought it would be better to create a very detailed 31-page PDF document that goes over the entire build step by step, and in this video I would just go over things to look out for and some tips and tricks while making the machine. If you check out the Buster Beagle 3D Facebook group or the Buster Beagle 3D online store website, you can find a full build of materials as well as frequently asked questions that might answer any of the questions that you might have. The first question I wanted to address here is if you have already built one of the MK1 or MK2 machines, can you upgrade to this MK3 machine? And the answer is absolutely yes. The latest version was designed in such a way that you can use many of the parts you already have to make this machine, including the chambers and all of the electronics. The frame of the MK3 is almost exactly the same as the MK2 frame as well. The only difference between the MK2 frame and this frame is that the MK2 frame is about 50 millimeters wider. I don't think it would really be an issue if you just reuse the MK2 frame as is, but I wanted to give the machine the least amount of area to flex, which is why I made this machine a little more narrow. You have to remember that all of the pressure of this machine is really pushing up on the frame, so you wanted to make sure that it's supported as well as it can be and not have too many unsupported horizontal spans. This also leads to the first thing I want to point out when building this machine. If you plan on building this machine and are not using a drill press vise similar to what I have here, you really need to be careful that you either clamp or bolt down all of the points near the vertical supports of the frame, or have some other kind of metal plate that sits on top of the bottom frame spans and spans the distance from the front to the back. If these are not either clamped down or spanned by a 4-inch vise or a metal plate, the pressure of the piston is liable to bend and flex the entire frame. So just something to look out for. The next thing I wanted to point out before I go deeper into the pneumatics and wiring of this machine was that it was designed to be built with 2 different sized pneumatic cylinders. The first that you see here is the SC100 pneumatic cylinder, which is the more powerful cylinder options for this machine. To be able to use this option, you have to adjust this whole top plate higher like you see here, and the reason for that is that the piston on the SC100 has a diameter too large to fit inside of the chamber. It requires a plunger extension that sits in between the cylinder and the chambers. So when you press the button and the piston comes down, the only part that enters the chamber is the plunger extension and not the piston itself. If you wanted to use the smaller and less powerful cylinder, you can use the SC63 pneumatic cylinder that you can see me using in the first video. This cylinder is mounted lower and does not need a plunger extension when used with the MK3 chamber. The diameter of the piston on the SC63 is smaller than the diameter of the inside bore of the heat chamber, so it's able to enter the chamber and no plunger extension is required. Again, if you are upgrading an older chamber from the MK2 or MK1 machines, you can also use either pneumatic cylinder, but as the chambers are slightly smaller, you would have to use one of the plunger extensions with either pneumatic cylinder, as the inside diameter is smaller than both pistons. Check the first page of the build PDF, which should show you which ones you will need for the setup that you want to make. The version of the pneumatic cylinder you plan on using might also change a few of the components you need to build the machine, such as some of the sizes of the pneumatic connectors and things like the length of the linear rails. If you check out the bill of materials, you can see a blue and red highlights. If the highlight is blue, then these are the components you need for the SC100 cylinder. If it is red, then that is what you need for the SC63 cylinder. You won't need both. If you look at the top metal plate that holds the pneumatic cylinder, you will notice 2 sets of holes that will allow you to use either version. So these outer holes are for the SC100 and these inner holes are the ones for the SC63. So you can use either cylinder with this plate. I also sell these plates on my online store, or you can find the step files in the build of materials if you want to machine them yourself. So regardless of what pneumatic cylinder you choose, you're going to also need an air compressor to power them. If you are using the SC63 cylinder, you need at least a 1-gallon air compressor, but I would recommend a 2-gallon just to be safe. I used the SC63 with my 1-gallon quiet air compressor from Harbor Freight, but it really was not enough volume to properly use for my SC100 cylinder. For the SC100, I would definitely recommend at least a 2-gallon or higher air compressor so that you don't run out of pressure during the shot. Since I already had the 1-gallon air compressor and didn't want to purchase a whole new air compressor, I ended up purchasing a 5-gallon air tank, also from Harbor Freight, and fitted it in line with the compressor to increase the total volume up to 6 gallons for around $35. It works great. So now I want to go over the electronics, as for many people it can be the most intimidating part of the build. The electronic setup of this machine has not changed since the 2 earlier versions of the machine. You can find a complete guide to this in the build PDF, with simple intuitive wiring diagrams, as well as another sheet that visually shows you how to put it all together. But I'll go over it a little bit now so that I can explain a few things to look for. So the next thing I want to go over is the wiring of the machine. And I'm going to go over kind of some things to look out for when putting this all together. So if you look at the PDF, you'll notice that I have this wiring diagram here. And this is to go over kind of the lengths you want for all of the wires. So you can just kind of grab some, this is 18 gauge wire, and pull it out to the lengths on this diagram. And you'll notice that this has things where it tells you where everything is supposed to hook up to. You can also use the other diagram that is in the PDF that gives kind of a chart where everything goes. But I wanted to point out a couple of things to kind of look out for when using this. The first thing would be the PID controller. So here is the Rex C100 PID controller. But one thing to kind of look out for on these is you'll notice this is a Rex C100 PID controller, and so is this. And if you'll notice, from the front, these look the same. They function exactly the same. And you'll notice that this one on the bottom is shorter than this one on the top. Now, the length really doesn't have anything to do with how these function. But I did notice that on some of these, you'll notice that if you look at the 4 and 5 position on this that go to the solid state relay, you'll notice that the number 4 position on this has a little positive sign next to it. And on the bottom here, it has a negative sign. So for whatever reason, these two have inverse of each other for 4 and 5. But the way that the diagram is set, it's where 4 is positive and 5 is negative. So if you have one of these other smaller PID controllers and 4 is negative and 5 is positive, all that you have to do is swap the 4 and 5 wires. So 4 would then go to solid state relay 4, and PID 5 would then go to solid state relay 3. But that's only if you're using this little one. And a good way to tell is you've turned everything on and the bands don't heat up. That's always kind of the first thing I look for, is to make sure that this isn't 4 isn't negative. If it is, just swap those wires. So I'm going to be using the one where 4 is positive, and just because that's the way that it's set up in this diagram, and it'll just make it easier for right now. The next thing that we have here is this AC switch. And now it doesn't matter if you have a green button or if you have a red button, they still function the exact same. So a couple of things to look out for on this device. Sometimes you get these and the button is installed backwards. So the way you can tell that is, if you notice on the back here, if you look at the 1 and 3 position, you'll notice that these two terminals are closer to each other. So if you look on this, you'll see that the 3 and 1 terminal are closer. And so that's how you know that the button is set up in the exact same way that this diagram is set up. The other thing that some people kind of run into, and it really just depends on where you buy this switch, but sometimes for whatever reason, it doesn't come with a fuse already installed. So if you plug everything in, this light doesn't turn on or nothing happens, just make sure that you have a fuse inside of there to begin with. Because I have seen some people get these and the fuse is not installed. So just make sure that there is a fuse in there. And then the last thing would be the solid state relay. And you can see that it already has the numbers on it. So 1, 2, 4, and 3. And that corresponds to the exact same thing on this diagram. Okay, so now I'm just going to take these 18 gauge wires, I'm going to pull them across the sheet right here, and then attach all of my terminals to all this wiring setup, and then we'll go through the actual connecting it to the PID controller. And I do recommend connecting all of the wires to the PID controller before you push it into the enclosure, It's just an easier way to put everything together. It's much harder to unscrew these things and then put the terminals on when this is already pushed into the enclosure on the frame. So I like to do all of that setup first and then push it in. Actually, the last thing that I wanted to kind of go over as something to look out for when you're wiring this is these thermocouple temperature sensor wires. If you notice on here, we have 10 being the red terminal and blue for the number 9 terminal. Now, if you hook up your machine and when you plug it in and you automatically get negative readings on your PID controller, what that means is that these wires have been installed backwards. So if you're getting a negative reading, you want to just swap these two wires and you won't have that negative reading anymore. Because what's going to happen is it's going to act like it's doing a negative reading, and then it's just going to get to a certain negative value and then turn off, because it's not expecting you to be able to achieve a negative value as high as it is. So that's just another thing to look out for and troubleshoot if you're running into issues with this. Okay, so now I'm going to put together all of these wires, and I'll speed that up, and then we'll go from there. Okay, so there you have it. Now I've created all of the wires for this. When it comes to what I'm going to hook up right now, first and foremost, you can hook up some of the things that go to the AC switch because these are not going to be connected to anything till later. So if you look at one down here where it says AC1 goes to AC5. So right now I can take my AC1, which is right here at the bottom, push that in, and that goes to AC5, which is this top one right here. Okay, and then I'm going to take this AC3, which is up here, AC3, and AC3 goes to AC6. So I'm going to push that in. Okay, so these are the parts that kind of connect to themselves on the switch, and then these other ones are going to connect to other terminals. So if I was looking at AC4, we see that AC4 is going to connect to PID1, which is this first terminal up here, but we're going to do all that later. So I'm just going to set this aside for right now. If you need an explanation of what all of these things are, you should have a diagram on the side that goes over everything. So 1 and 2 are going to be the voltage coming in. 4 and 5 are what is going to go to the solid state relay. We're not worried about these alarms, which in this particular one, it didn't even come with the terminals. And then 9 and 10 go to that thermocoupler, which is the temperature sensor on this device. Another thing that I like to do when I'm putting these together is I like to have it so that the terminals are coming from the inside. So so when these are connected, I would never have something kind of coming off to the side over here, because that's going to conflict with the enclosure when we put that all together. So I like to remove these screws altogether and then take what we see right here as PID1. So PID1 goes into PID1 over here. And I like to take this so that the terminal is coming from the opposite side. So when it gets tucked into the enclosure, nothing is going to scrape up against the wall. Everything is kind of tucked in. So you'll see that I have the terminal coming from the right side of this screw and not from the other side. So this is my PID1, which was right here, and then this is PID2. So I'm going to do the same thing for PID 2. So there we go for PID 2. And then I'm just going to go down the line. First I'll connect PID 4. You can also see that even outside of the enclosure, these are not the easiest things in the world to connect. Okay, so now I have PID 1, PID 2, PID 4, and this is PID 5. Okay, so all of those wires are connected. And then I am going to connect my temperature sensor wire now. Again, you'll notice that I will bend these to a 90-degree angle just to make it easier. Again, remember that the blue is in the number 9 position over here. And then finally the red in the 10 position. So what we're left with here is this green wire that is going to go from AC7, which is on the power switch itself. And that's going to go from AC7 to the ground wire or the ground connection on the frame. And then we have this wire here that is going to go from solid state relay 1, and this is going to connect to the band heater. Okay, so for now, these are all the connections, and the rest of the connections are going to be done with this pushed into the enclosure. So the first thing we're going to do is route all of the wires from the front of the enclosure and then push the PID controller in, making sure that the display is right side up. Then in the back here, I'm taking the thermocouple wire as well as the wire that is going to be going to the band heater, which is this black wire, and they're going through the hole on the side of the enclosure. Now here, what I want to do to the solid state relay is we're going to take some of this thermal paste and we're going to do a thin layer on the metal side of this solid state relay. Now you're not going to see me do it here because I actually ran out, but what we'll do is do a thin layer on this solid state relay, then we'll put the fin onto that and then use the screws that should have come with the fin to attach the solid state relay to the fin. First thing I'm going to attach here is PID 5 to solid state relay 4. Then I'm going to connect PID 4 to solid state relay 3. So once I have those connected, I can slide it into the top of the enclosure. Next, I'm going to install PID 1 to solid state relay 2, which is here on the right. Finally, I'm going to take that other wire that I made earlier, which is going to go to the band heater, and route it through the hole, and then that is going to attach to solid state relay 1. And just tighten everything up. So with the switch, the first thing I want to connect is this ground wire. So the ground wire goes to AC switch 7, which is the switch in the bottom. Then I'm going to take the back plate that was 3D printed for this enclosure, and I'm going to install the switch into it. So with that installed, I am going to connect PID 1 to AC switch 4. Now the only terminal left is AC2, and AC2 goes to PID2. So now with everything connected, I'm going to take that ground wire and loop it through the hole on the side of the enclosure. And now I can close everything up. Now I'm installing 1/2" number 4 wood screws. The only thing that I should have coming out of the side is these 2 black wires that go to the band heaters, a green wire that will go to the ground that I will mount to the frame, and this thermocoupler wire, which is the temperature sensor. So while I'm up here, I'm going to attach the ground wire. So the ground wire can be attached to any bolt on the frame. I'm going to attach it to these screws that we're holding on the linear rails and attach it and tighten it from the bottom. Okay, now we're going to move on to the band heaters. And so I've already slipped 2 of the band heaters over the heating chamber, and you want to do this after you've already installed the heat chamber into the middle plate. So as you can see here, these are these band heaters. These are from my store. You don't have to purchase them from my store, but I did have these made specifically so that the size would cover the largest area possible of the chamber. So you do get a more even heating along the chamber. So as you can see, they've been installed here. I've taken the covers off, and you want to install them in such a way so that there is a hole left for where the thermocoupler wire is going to go. And you can also see that I've installed them in such a way that the wires meet up in the middle. And this is kind of just more of a personal preference, but I like to do that to try to keep the wires away from pinching at the top or getting too close to where the plastic comes out at the bottom. So when you install these, again, you're going to put the band heaters on first, and then I'm going to go in and install the covers on top of it. So I'll do that right now. So now for the bottom band heater, if you notice, if I were to put the bottom band heater clamp on, so if I were to put that on and I was to tighten this, the problem is I wouldn't really have anywhere to install the thermocoupler wire because the part where it closes wouldn't allow me to get into that hole anymore. So the way around that is to take the bottom clamp, I'm going to take it off, and then if you turn it around and drill a hole in the front side of the clamp, then what you can do is when you install it backwards, and then once you tighten everything, you're going to have a spot for that thermocoupler wire to go through that the clamp on the band heater, and the clamp holding the band heater on is not going to interfere with anything. Okay, so now I'm going to go over the wiring. So if you'll notice, these 2 bands were installed where the wires were facing each other, so one was upside down and one was right side up. So what I want to do is I want to take the 2 wires that were on one side, and I'm going to connect these 2 together and then connect those 2 to one of the black wires that was coming from the top. And then I'm going to take the 2 wires that are on the right side, and I'm going to do the same thing. I'm going to connect these 2 together and then connect it to the other black wire that I have on the top. So if you refer to the build PDF, you'll see how these are supposed to be wired. There is a alternate wiring for those who are not in the US, where instead of hooking them up like parallel like I'm going to be doing here, you hook the band heaters up in series. So do refer to that PDF for how to hook up the 110 volt band heaters in either the US or abroad. And then to connect these, you can pretty much connect them however you want. I like to use these solder and seal connectors. So the way these work is you would install both, you would twist these together, and then you would install one side of this into the solder and seal connector. So you want to push it up until it gets to where that little piece of solder is in there. And then what you would do is for the black wire, you would just put it in on the other side, again, all the way up to where that piece of solder is. And then you just take a heat gun or a lighter or something like that, and you heat up this until it melts that solder, and then this makes this one connection. You don't have to use these connectors. I mean, you could twist all of these things together, but I just like doing that. So you would just do that for both sides. So again, top and bottom band heater on one side, those are together, and then top and bottom band heater on the other side, and those are together, and that would be attached to the other wire. So now that the machine is ready to test, I wanted to talk a little bit of how to tune your machine, and more specifically how to set the max temp of your band heaters so that the machine doesn't try to heat them above their max rating, which is 300 degrees Celsius if you purchase the bands from my store. It is normal to see the bands smoking slightly when you first turn on your machine, but it is not normal for the bands to be glowing bright red. Allowing the bands to overheat for too long can burn them out, so this is how to adjust those settings. Okay, so the next thing I want to go over is how to calibrate your PID controller. When you first turn on your machine, what you want to do is you want to set some certain settings on your PID controller so that it functions properly, as well as set the max temperature of the heater bands that you're using with the machine. Now, if you're using my heater bands again, the maximum temperature for those is 300 degrees Celsius. Okay, so I'm just going to turn on the machine. And the first thing I would recommend doing when doing this is hit set and turn that temperature down all the way to 0. And that's just so that we can adjust some of these settings without the machine trying to heat up. So I'm going to hit set. Okay, so right now the top value is what the heater bands, or what the temperature of the machine is right now, and the bottom is what temperature we're setting the plastic to melt to. Another thing to keep in mind is immediately when you turn on this machine, your band heaters will heat up. So do not touch them. Don't try to put your finger on it to see if they're heating up. Trust me, they'll be heating up. So do not touch the band heaters as soon as this is on. Okay? All right, so the first thing that we want to do is hold down the set and the left arrow. And then over here we'll see COD. We want to set COD to 1 and then hit set. And this is going to bring us into the section where we can change a couple of settings. This first setting, Y, is actually referring to the K-style thermal coupler that we're using. So that's fine. We'll hit set again. This SSL is the minimum temperature that your PID controller can read. So right now it's -50, so we don't ever really need it to go below 0. So I'm going to move that back up to 0, hit set again. And then right here, this SLH, this one's really important because this is the max temperature that the PID controller thinks that your heater bands can achieve. So we want to bring that all the way down to 300 because that's the max temperature of the band heaters, specifically the ones that I sell. But a lot of the mica bands, 300 degrees Celsius is the max temperature. Okay, I'm going to hit set. Okay, so that's all I have to do for this one right now. And so after 30 seconds or so, it'll go back to the main screen, and then we can proceed to the next step. On this one, you can also just turn off the back and turn it back on. Okay. All right. So now what we want to do is change some of the settings of the PID controller. Now, I'm going to tell you the settings that I'm using for my particular PID controller, and then I'll show you how, if these settings don't work, how you can automatically find the proper settings for your machine. Okay, so the first thing that we want to do is hold down the Set button. Okay, and instead of just pressing it once to change the temperature, if you hold it down, it's going to take you to this other menu. AL, this is just alarm 1, that's fine. I'm going to hit Set again. ARU, this is what I'm going to use later to do an automatic settings, but I'm going to skip that for now. So I'm going to set P to 64 and then hit Set. I'm going to set to 280. Hit Set. D, I'm going to set to 70. Hit Set. AR, I'm going to set to 25. I'm going to hit Set again. And R, I'm going to set to 1. And then hit Set. So these are the settings that I'm going to use for my machine. These are ones that I've already found work good for my setup. Now, if you have a slightly different PID controller, or it could be a myriad of different factors that these are not the proper settings that work for you. You have different band heaters or whatever. Now I'm going to go over how to set these settings automatically for your machine. Okay, I've restarted the machine now. So before you set up the automatic tuning, what you need to do is you need to increase the temperature that you want to achieve before you go and run the automatic setup. So right now I have it set to 0, so the band shouldn't actually be turning on. So I'm going to set this to, I'm going to say about around 250. So I'm going to just press Set very quickly. And then SU, I'm going to change to, I'm going to go to 225. Okay, and then I'll hit Set. And so as you can see, the band heaters have now turned on, and you want to, again, make sure that you're not touching anything because it's going to be very, very, very hot. But now I want to run the automatic procedure where it tries to find the settings of the PID controller for this particular setup. So I'm going to hold down Set. I'm going to press Set again. And it's this ARU function. So if you set ARU to 1 and then hit Set, you see this little button here. It has a little, it's probably hard to see, but it has an AT on it. It's for automatic tuning. And what that is doing is it's going to go through and it's going to automatically set all of those settings that we were setting before. Now, it's going to wipe out any of the settings that we manually put in. And the way it's going to work is the PID controller is going to try to raise the temperature until it gets to that 225 degrees that I set before, and it's going to overshoot it. And what it's trying to do is figure out how much power it has to give the band heaters so that it can achieve that 225 degrees Celsius without overshooting it. So what you're going to see, and this will go back so now it's gone back to the main screen because it's been 30 seconds. So what's going to happen is this number is going to go above 225, and then it'll turn the bands off, and then it'll go below 225, and then it'll turn the bands back on, go above, go below, go above, go below. So it'll run that cycle 3 different times, And once it runs it 3 different times, then it'll go through and set all of the settings as it sees from running that cycle. And then you'll see this AT flashing light turn off. If this flashing light is still on, then that means that the cycle has not completed yet, and you need to just let it be. You can't turn it off at that time, otherwise the cycle won't complete. So if those other settings that I showed you before are not working for you, that's how you set up your automatic tuning for your PID controller. And then after that, it should just raise up to the proper temperature and linger around whatever that proper temperature is at all times. The next thing that I wanted to go over was recommendations for the certain parts to purchase for this machine. The first recommendation is that you purchase the 2028 corner brackets and not the 2020 versions. And the reason for that is that these are slightly larger and able to accommodate a socket head screw instead of a button head screw. I recommend the socket head screws because it's much easier to tighten without stripping the screw head, and you really want to be able to tighten everything down. I also recommend that for everywhere the T-nuts are called for, that you use the full slide-in T-nuts and not the self-turning type for everywhere except for the corner braces that go on last. These corner plates do have the button head screws and self-turning nuts in this version. I would also recommend the shaft collars you purchase for the linear rods that hold up the middle plate to either be a tightening or 2-part clamp with the large socket head screws rather than a version with a simple set screw. Again, this is to be able to tighten the screws without worry of stripping that little set screw, which could be a big pain if that ever happens. The last thing I wanted to talk about was improvising. When I first posted the build of materials with links, it was met with a pretty quick sellout of many of the links that I listed. That doesn't mean that you can't buy those parts anymore, but that you either have to source them from somewhere else or get a little creative as to how to put things together. For instance, the springs that I list in the bottom plates are these yellow compression springs that are really from large 3D printers. If you're having a hard time finding these, you can replace these with another 10mm inner diameter spring with enough power to keep the weight of the chamber up. If you look at the first video, I was using the blue springs, which I felt were a little bit too stiff, but could still work. Another issue people may run into is with the pneumatics, where they can't find the exact button or they can't find the speed control valve that hooks up directly to the port on the cylinder. So if you watch the first look at this machine, you'll notice that I have a little bit different setup than before. I opted to go with just a manual pneumatic button instead of one that was placed inside of the PID enclosure that had an electronic button. People might run into things where they can't find this exact button, or I've also seen where you have these speed control valves on the side here. So these speed control valves go from a 1/2-inch thread down to a 1/4-inch tube. Now, if you can't find, let's say, this particular piece where it's a 1/2-inch thread that goes down to the tube, what you could do is just have a 1/2-inch port over here that attaches to the cylinder, and then put the speed controller either in line on this tube, or you can even attach the speed controller to your button. So let's say that this port right here, which is a 1/4-inch port, you could get a 1/4-inch speed control valve, and then that would connect the tube to the pneumatic cylinder itself. The point is, there's different ways to set up the pneumatics so that it works. It's a system that's independent from the electrical, so you can connect it up however you see fit. Again, if you get stuck or have any questions, feel free to check out the frequently asked questions page on the website, and maybe even take a look through the older Buster Beagle 3D injection molding videos on my YouTube channel that might give you a better idea of what these machines are all about. Also, do consider joining the Buster Beagle 3D Facebook group with members from all over the world who are always willing to help and share their progress with their projects. I also wanted to give a heartfelt thank you to all of you for not only watching these videos, but to the hundreds of you from all over the world who have already put together one of the Buster Beagle 3D machines. Thank you so much. I really had no idea just over a year ago that anybody would have even watched one of my videos, much less built anything I designed. Now I'm on my third machine and part of a growing community of makers interested in small-scale injection molding at home. If you like this, please do hit that like button and consider subscribing to my channel for more content coming out soon dealing with injection molding. I have a few plastic recycling ideas I'm pursuing, so stay tuned for that. Thanks again, and we'll see you next time.